So this side is 12 and this side is 6. And so we're going to match. This side is 6. So then do it twice and it fits. So that's the middle.
So let me interrupt you for a second. How would that change for the centroid? Centroid are formed by 4 or by 3 whats? Medians. Good. And the median means I just need the midpoint connected to the opposite side. So if I treat this as a slope triangle, 1, 2, 3, 4, so I go over half as much, 2, 1, 2, 3, 4, 5, 6, 7, 8, and go half as much, so up 4, 1, 2, 3, 4. That finds me that midpoint. And if I connect it to the opposite vertex, that gives me a median. And if I do it again, 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. So I need to go over half as much. 1, 2, 3, 4. Up 1, 2, 3, 4. That finds that midpoint. And if I connect that midpoint to the opposite vertex, I create a second median. And these two medians meet in a point of intersection, which is called the centroid. This point is 1, 2, 3, 4, 5, up 1. What? Okay. Now it turns out that actually centroids have a really cool one. You know how we're talking about 4 different centers? The centroid, the incenter, the circumcenter, and the orthocenter. In my mind, this is really the true center, because it's the center of gravity. And it turns out that if you were to take each of the coordinates we're talking about here, in other words, this point F is 5, 9. This point G is 9, 1. And this point H is 1, -7. And just average them all. Let's see, that would mean that my X value is 5 + 9 + 1 over how many? 3. My Y value is 9 + 1 + -7 over 3. I get 15 over 3 and 3 over 3. 15 over 3 is 5. 3 over 3 is 1. That is my centroid. So that's a pretty cool little shortcut but it only works for the centroid. What about the orthocenter? What's the orthocenter formed by? Altitudes. How do I find an altitude? Good. And you're just quoting the words off of our chart, right? Vertex and perpendicular. So let's say I want to go to this side to this vertex. I know it's going to go from B. The question is, how does it come down? At what steepness? So let's find our slope here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up 1, 2, 3, 4, 5, 6, 7, 8. Did I count that wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 9, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So 12 and 9. Well, I can't divide them both by 2 to find a midpoint. I don't even need the midpoint though. My slope is equal to 9 over 12, which is really 3/4. So what's the slope that's perpendicular to that? -4/3. But I don't know where to start from on this line, but I do know that it's going to go through this point B. So from that point B, I go a rise over run of this, down 1, 2, 3, 4, over 1, 2, 3. And I'll connect those 2 points, and that's going to be my altitude. Now, altitude would just be this little length here. But because I'm looking for the point of intersection, I'm making it super long. And then let's do it from BD, because what's the slope of BD? What do you call a slope that's straight up and down? That would be the equation of it, right? In which case, I can't put it in a y equals mx plus b. There is no slope. This slope is undefined. And the negative reciprocal of that would be horizontal. So I don't need to do any calculations here whatsoever. From C, I just need to go exactly horizontally. This then is my orthocenter. 1, 2, 3, 4, 5, 6, 7, 2, 3, 4. So -7, 4. Last part. What is this center? It's a solid guess, but you think we should do more than just guess?
Yeah.
How can we distinguish between them? We could do angle bisectors and just see if they fit. What if we just tried to see if like this point and this point and the midpoint are collinear? What does that mean if they're collinear? Then it would be a median, right? It could actually be a perpendicular bisector too, couldn't it? Because it would have to be perpendicular. But the question is, like, if I do it straight up and down, notice that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I go over 1, 2, 3, 4, 5, 6, it's a vertical line through WP in this, which means that not only is this a perpendicular bisector, but it's going through this point. So it's also a median. What kind of triangle is this? It's an isosceles triangle. So this is going to mess with us because it's not only actually perpendicular bisector and a median, it's also an altitude and it's an angle bisector. So if this one doesn't help us in any way, we have to go this way. So let's see, to get over to this, this was 6 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I go for the midpoint, 1, 2, 3, 4, 5, 6 up, 1, 2, 3, 3 over. There's my midpoint. These are in the same direction, aren't they? This slope was 12 over 6. So -12 over 6, which is -2 over 1. If I were to go at the perpendicular slope, down 1 over 2, down 1 over 2, it misses this point. What does that tell me? if these three are collinear through this perpendicular, excuse me, through this bisected point, midpoint, but it's not a right angle. It can't be the circumcenter because those aren't perpendicular bisectors, right? And it can't be the orthocenter because it's not perpendicular. But is this a median? Yes, it is. Therefore, it's the centroid. Different way at looking at this. Does it help you see what you're supposed to know about these centers? Okay, thank you for the courtesy. Yeah. Okay. This is what we're going to work on today. We're actually moving on to the next piece of this unit, which talks about other features of a triangle. So if I were to give you any three lengths, let's say I were to give you this length and this length and another length. Could you make a triangle out of those three lengths? Okay. So any three lengths I give you can make a triangle. No? Yes? What about those three lengths? Why not? One is way too long, isn't it? Like if I put this one at the end here and this one at the end here, they don't fold together to make a triangle. These two aren't long enough to like land there and make a point. So this first rule that we're going to look at here says that a triangle exists if and only if the sum of the two smaller sides is what? The long side? Do you want it to be equal? Bigger than, right, is larger than the largest side. Well, let's think about that. It's a good question. If I ended up with a segment here and another segment here and another segment here, such that like if this was 5 and this was 2 and this was 3, what would happen when I try to collapse it into a triangle? It would just be two straight lines on top of each other, wouldn't it? So it has to be longer than that. It's got to be 2 plus, and then it would make that nice little peaked segment we're looking for. So this first section is really pretty straightforward. I'm going to take my two not largest sides and say, is their sum when compared to 24 greater than it? And I put a little question mark above that. It's a little hard to see, but I put a greater than sign with a question mark above it. I think that's patent pending, Mr. Erlin. Doesn't exist in the real world of mathematics. But then we can see that 25 is greater than 24, which is what we want. Therefore, we can say, yes, a triangle. How about number 5? How do I start it?
20 plus 22 is greater than 50.
And when I add those together, I get 50 equals 50. That's not greater than, so I say no, not a triangle. Doesn't work. Any questions on using the triangle inequality theorem to determine if it's a triangle? Yeah, Mark.
Can you go back up to the right?
The triangle exists if and only if the sum of the two smaller sides is larger than the largest side. So let's look at number 9. Now we're going to do the same kind of thing in a slightly different way. Now we've got 2 of the sides of the triangles. We've got 14 and we've got 22. And we want to think about what other sides would work. We know that 1,000 wouldn't work. But is there a range we could get that would work? Yeah. Like, would 50 work? 14 plus 22 would be 36. That's less than 50. We need them to add to more than 50. So that wouldn't work. Would 40 work? What's the highest number it could be that would work?
35.
35.9999, right? In other words, we have to have it be less than 36, not equal to 36, less than 36. We'll call X that side. And is there a minimum that X could be? What would that be? 0, but 0 plus 14 would be less than 22. That wouldn't work. And 1 plus 14 is less than 22, so that wouldn't work.
9.
Ooh, good. 9 would work. What's the number that wouldn't work? Where's the first case where it wouldn't work?
8.
8. And how'd you get that? This one was 22 plus 14, wasn't it? What was this one? 22 minus 14. And it turns out that's exactly the formula we want to use. So if I've got a triangle with A, B, and side X for the third side, the X will always be trapped between A plus B and A minus B. The only problem is we don't know if A is bigger or smaller than B. So what we can do is claim that this is absolute value of A minus B, and that will then force it. So that even if I, by mistake, did 14 minus 22, instead of negative 8, it would force it to be positive 8. So please do number 11 yourselves. What would that become? Don't say it out loud on the count of 3. In a moment, I'll have you do a choral response. Okay, on the count of 3, please tell me what number belongs here. The smallest number could possibly not be. 1, 2, 3.
9.
Yeah, I didn't phrase that real well. 8 is what goes here, right? That's the last number that it cannot be. What number goes here? 1, 2, 3. 14. In other words, we're subtracting here 11 minus 3, and we're adding here 11 plus 3. Any questions on these? How would this be different from number 15, the way they phrase it?
You can check off what could be and what would be X.
Right? So would you do it this way? Would you say, okay, 34, that would be the largest one. So 15 plus 27 is 42. That's larger, so that works?
Yep.
Could do that, but could we also just do the little range? 15 plus 27 is 42. 27 minus 15 is 12. Is this between those two values? Is this between those two values? No. Is this between those two values? Is this? No. So those are the 3 answers. Okay, page 2. Wish I were a cartoonist. This would be a perfect opportunity. And maybe that's because I grew up as a kid watching cartoons. And I can always visualize this like mountaintop with this caveman sitting up there on the mountaintop. And inevitably this big dinosaur comes up and he's going to threaten to eat the caveman, right? And what does the caveman do to save himself? Picture this big mouth coming at him. Oh, come on. You guys have seen these cartoons too. Give you a hint. There's like a bone or a stick down here.
Oh, he jumps in.
He turns into a
He
triangle.
turns into a
He puts it in the mouth so he can't close his mouth, right? There's this big mouth coming at him and he sticks this bone in the mouth and suddenly the dinosaur's like, arr, 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 and he goes running away. It's always just the right size. Funny. But that's actually the question right here, is if his mouth was really small, you wouldn't need a very big bone, would you? But if he had a bigger mouth, you'd need a bigger bone. This is actually the rule we're about to work with in geometry. Who says cartoons don't help you? What we're going to say is that if in fact you're looking at a triangle, this small side, because 7 is smaller than 10 or 13, is going to be facing the smallest angle. The smallest angle is always opposite the smallest side. And the largest side is opposite the largest angle. Largest angle is opposite the largest side. This doesn't actually help us find the actual angle measures, but if I just wanted you to list the angles in order from least to greatest, which would be the smallest angle in this picture? Angle A. Why? Because if that mouth is only open that much and a 7-foot bone fits in there, it's not a very big angle. What's the second? C. And what's the biggest? Angle B. So now apply that here. List the angles from least to greatest. And I will say that that sounds very elementary to say least to greatest. We have one word that encapsulates that. What does that mean? What's that word? In ascending order. So if we asked to do these in ascending order, what would be our first angle? Angle M, and our second angle? Angle P, and then angle M. We could also do them in greatest to least. What's that called? Good, descending. Doesn't really change the process except what order I put them in. We can do the same thing going from angles to sides. The smallest side is always opposite the what? Smallest angle. The largest side is always opposite the largest angle. But there is a little twist in this one. What's the largest side? What's the smallest side? You sure? We don't know. We're missing one of the angles. If only we knew something called the triangle angle sum theorem. Do you know what the angles in a triangle add up to? See, you knew that. So we could say that measure of angle E plus measure of angle D plus measure of angle F equals 180. In this case, we'd know that that's 42 plus 103 plus F equals 180. 145 plus F equals 180. So F is 35. Now that we see that this one's 35, we want to go least to greatest. What's the smallest side here? If this is the smallest angle, it's way over here. It's the smallest side would be ED. What's the mediumest side? TF. The largest side would be EF. Now, inevitably, I find that some people struggle a little bit with this. So let me just try this a slightly different way. We want these three things to add up to 180. So 31 plus K plus 57 equals 180. 88 plus K equals 180. So K is 92. And what I'm going to suggest is that we start by listing the angles. We want to go least to greatest. What's the smallest angle? J, which is 31 degrees. What's the mediumest angle? 57, which is L. And the biggest angle is 92, which is K. If I want to figure out what side is opposite J in triangle JKL, it's the letters I'm not using. I'm already using J as the angle, so what's the side that's opposite it? What's the side that's opposite L? JK. What's the side that's opposite K? JL. For some people, that works better to be able to find what those angles are and the sides are. Okay, page 3. So now we're getting into two triangles. We see that this triangle has a side length that's equal to a side length in this triangle. And these two side lengths are the same. So these triangles are really close to being identical, congruent, aren't they? But they're not quite. What this theorem says is if they're almost the same, and the measure of angle A, make sure I'm doing this the right place, just a second. Yeah, measure of angle A is bigger than the measure of angle D. This one's bigger than this one. What can you say about BC versus EF? Yeah, BC is going to be bigger, same idea, than EF. And the opposite works as well, the converse. If BC is bigger than EF, then what? If this is bigger than this, then A is bigger than D. It's kind of a limited theorem, right? You got to have two triangles that are almost the same, and it doesn't even give you the length of the side. It just tells you which one's bigger. So here's 9 and 15. Here's 9 and 15. This angle trapped in between is 79. This is only 74. So which is bigger, KL or PM? KL is bigger because it's facing the bigger angle. What about number 3? How is that one harder? Do we have the two sides? Well, we know that 3 is there and 3 is there. So there's one pair of sides. Is there another pair of sides that are the same? Isn't this side the same as itself, reflexive? So now that means that this triangle with 53 and this triangle with the missing angle have to be compared. So let's find what the missing angle here is. 32 plus 93 plus X equals 180. 125 plus X equals 180, so X equals 55. if this one's 53 and this one's 55, is WX bigger or smaller than XY? Smaller. Okay. Two more ways we're going to look at this same concept of inequalities in triangles. Please go to the second to last page, starting on problem number 5. We're given triangle FGH. And what we're trying to list is the sides in order from least to greatest. But they give us the angles in algebraic expressions. What do you know about the angles in a triangle? They add up to 180. So I can create this equation, and then I can replace it with the algebraic equivalents. That looks like a one variable linear equation. So I've got 5 x's and 12 x's and 4 x's all on the same side of the equation. So that's 21 x's. 6 minus 4 is 2 plus 31 is 33 equals 180. I'm going to subtract 33 from both sides. So I get 21x equals 147. Divide by 21. And I get x equals 7. But the whole point here is that I want to find the angles. So the measure of angle F is going to be 5 times whatever x is, which we just found is 7. So 35 plus 6 is 41 degrees. Yep. Measure of angle G would be 12 times 7 minus 4. 12 times 7 is 84. Minus 4 is 80 for G. Measure of angle H is 4 times 7 plus 31. 4 times 7 is 28, so 59. Now I want to list the sides in order from least to greatest. So what's the first side I'm going to list? Good, it's angle F, which means what side would I choose? GH. And if you wanted to do it that way, you could do it with angles first and say F, then H, then G. These are angles. But the real question is the sides. So the side that matches to opposite F is GH. What's the one opposite H? FG. What's the one opposite G? FH. Those are the sides listed least to greatest. Give you just a second to get caught up. One more manipulation. Okay, let's flip back a page. This one's a little bit tedious. So much so that please cross out number 3 and 4. We'll do one together and I'll have you do number 2. Now they're giving us the side lengths. Oops. Do the 3 side lengths in a triangle always add up to the same number like they do with angles? No. Small triangles add up to small numbers and big triangles add up to big numbers. It's not like angles. But what we said before is that we know that the 2 smaller ones have to add up to be bigger than the largest one. Which one do you think is the largest? QR? Okay, let's pretend that QR is the largest. That means that PQ plus PR has to be bigger than QR. So let's substitute 7x plus 13 plus x plus 27 is greater than 10x minus 2. Now we'll clean this up. I've got 7x and one more x on the same side, so that's 8x. 13 and 27 makes 40. It's greater than 10x minus 2. And I'm going to make a rookie move here. I'm going to bring my x's over to the left. So I'll subtract 10x from both sides. Negative 2x plus 40 is greater than negative 2. That means I move the 40 to the right by subtracting it. So I get negative 2x is greater than negative 42. And this is not an equation, right? This is an inequality. Is it basically the same as an equation, or does it have some differences? It's basically the same with one key issue. At this point, there's only one thing I can do that makes me treat it differently. When I divide by a what? When I divide by a negative number, as I'm about to do here. When I divide by a negative 2, I'm going to get x and 21, but what happens to my sign? It flips, doesn't it? It's going to become x is less than 21. So that gives us a bit of the range, but we're going to need a little bit more than that. Well, we said that QR was possibly the biggest one, but it doesn't have to be the biggest one. Maybe PQ is the biggest one. In which case QR plus PR is greater than PQ. So fill them in. Substitute the algebraic expressions. (11x plus 25 is greater than 7x plus 13. 4x plus 25 is greater than 13. 4x is greater than negative 12. So x is greater than negative 3. That gives me a second range, but have I really tried all options? I said that QR could be the biggest and PR could be the biggest, or PQ could be the biggest, but what about PR? It's possible that PQ plus QR has to be bigger than PR. So 7x plus 13 plus 10x minus 2 has to be bigger than x plus 27. 17x plus 11 has to be bigger than x plus 27. 16x has to be bigger than 16. So x has to be bigger than 1. So how do we tie all this together? Let's create a number line. And let's mark each of these. We know that x has to be greater than negative 3. We also know that x has to be less than 21. And we know that x has to be greater than 1. What we're looking for is the region where all three of these are true. This is the space where they all are true. So our answered range is between 1 and 21. Well, if it's -2, what ends up happening is QR ends up being a negative number. Which doesn't make sense. So all you do is you look for where all of them are true. -3 is true here, but the answer of 1 is not. So this doesn't count. It's only in here. Okay. You have the rest of the period to finish this packet up. That is your homework for day 35.